Hello and welcome dear students. I am Shravan Kumar, your maths lecturer. We have started the second topic of maths part 1, that is matrices. In the last lecture we have discussed the inverse of a matrix by adjoint method. Now today's topic is inverse of a matrix by elementary transformation. As we know, the transformation is of two types, row transformation and column transformation. For row transformation we have written a formula A into A inverse equals to I, and for column transformation A inverse into A equals to I. These are the two types of transformation, row transformation and column transformation. Now we will find the inverse of given matrix A. This matrix A is given 1, 2, 3, 4 whose order is 2 by 2, and we have to find the inverse of this matrix by using elementary transformation. Now if the word elementary row transformation is asked, then compulsory you have to do row transformation. If elementary transformation is asked, then either you can use row transformation or column transformation. You cannot use both the transformations simultaneously. Purely you have to do either row transformation or by column transformation. Here we are doing the inverse of a matrix by using row transformation. First, for finding inverse of a matrix, you have to check whether A inverse exists or not. For that, you have to find the determinant of matrix A. So the determinant of matrix A is 1 into 4, that is 4, minus 3 to the 6, minus 6, 4 minus 6 is minus 2, which is a non-zero number. Therefore, A inverse exists. A inverse exists means what? A is an invertible matrix. Now we know that these are the formula we have discussed in the last lecture. For row transformation, A into A inverse is equal to I, where I is the unit matrix of order 2. If here we have taken, if we take order 3, then here we have to write the identity matrix or unit matrix of order 3. Now put the value of A. What is A matrix is what? 1, 2, 3, 4. A inverse we have to find, and what is identity matrix of order 2? 1, 0, 0, 1. Now what are the basic three types of transformation we can use? There are three types of transformation. These are the three basic rules that we can use for transformation. First transformation is what? You can interchange any two rows or two columns. First transformation is what? You can interchange any two rows or two columns. First transformation. This is the first rule. Means we can interchange any two rows or two columns. Second transformation is what? You can divide or multiply any row or column by a non-zero number. Non-zero number. You can divide any row or column by any non-zero number. Third transformation is you can add or subtract two or more rows or columns. So there are basically three types of transformation. First one is what? We can interchange any two rows or two columns. Second transformation means what? Any row or column can be multiplied with a non-zero scalar, non-zero constant. Third transformation is what? Two rows or columns can be added or subtracted. These are the three rules that we have to use for transformation. So we have taken A is what? 1, 2, 3, 4, and A inverse we have to calculate. Now what is our target is? We have to reduce this matrix as identity matrix. We have to reduce this matrix as identity matrix. Why we reduce this matrix as identity matrix? Because we know that identity matrix behaves as one, like in algebra. 2 into 1 is 2, 3 into 1 is 3, 4 into 1 is 4. Similarly, in matrices, A into identity matrix is A, B into identity matrix is B, A into identity matrix is also A inverse, B into B inverse into identity matrix is B inverse. So if we reduce this matrix as identity matrix, then it becomes I into A inverse. So I into A inverse becomes what? A. I into A inverse becomes what? A inverse. We will get A with the value of A inverse, and our target is what? A inverse. To find A inverse by using transformation. So we have to reduce this matrix into what? Identity matrix. So what are the steps to reduce the given matrix into identity matrix? For row transformation, the first step is, for row transformation, here you have to bring as 1. First you have to bring A11, you have to make A11 as 1 by using three types of transformation. What are they? Three types of transformation is what? You can interchange any two rows, or you can divide with any non-zero, divide or multiply with any non-zero number. And third type of transformation means what? You can add or subtract two rows or column. So first target is what? You have to make A11 as 1. Next what you have to make A21. Second, A21 is what? 0. 1 0. If you use row transformation, then you have to go for column wise. A11 then 0. After that 1 and 0. You have to reduce this matrix as identity matrix. First we have to make A11 as 1. After that 0, 1 and 0 or 0 and 1. So here we are using R2 is going to change. R2 is what 3. If you do R2 minus 3 times of R1. If you multiply R1 by 3 and subtract from R2, you will get 0 here. So we are doing the transformation. R2 is going to change. R2 minus 3 times of R1. So R1 will remain as it is, and R2 is what 3 minus 3 is 0. 4 minus 6. 4 minus 6 here we have multiplied this matrix by 3. So 4 minus 6 is what minus 2. Same transformation we have to carry out in right hand side also. R1 will remain as it is. R1 is what 1 0. Here R2 is what R2 minus 3 times of R1. R2 minus 3 times of, so 0 minus 3 is what minus 3. And the last one is 1 minus 0. 1 minus 0 is what 1 only. Next is what, if you add these two matrices, then here you will get 0. Because our target is what, to reduce matrix A into identity matrix 1 0 0 1 or 1 0 1 0 1 0. So if you add these two rows, R1 plus R2, here you will get 0. So R1 plus R2 is what 1 plus 0 is 1. 1 plus 0 is what 1. 2 minus 2 is 0. 1 minus 3 is what minus 2. 0 plus 1 is 1. R1 plus R2, you have to carry out this transformation. Now next is what, here we have got what 1 0 0. The last target is what, here we have to bring 1. So the corner 1 is always obtained by dividing that number by the same number. Suppose this is minus 2, then you have to divide this number what minus 2. So minus 2 divided by minus 2 will get what 1. So we have reduced this matrix what, in the right hand side also you have to divide it by minus 2. So minus 3 divided by minus 2 is what 3 by 2, and 1 by minus 2 is what minus 1 by 2. So 1 0 0 1 becomes what identity matrix. Now this we can write as I, and I into anything is what that matrix only. I into A, I behaves as 1 like algebra. So I into A inverse is what? A inverse. So this is the value of A inverse by using row transformation. For column transformation you have to use the formula A inverse into A equals to I. For column transformation you have to use that formula A inverse into A equals to I. So we have to find A inverse, put the value of A and identity matrix. And for column transformation you have to go row wise. You cannot use simultaneously row and column transformation. Either you have to use row transformation or column transformation. So for column transformation, you have to bring first is what 1, then 0 row wise. If you use column transformation, then you have to go row wise 1 0, then 0 1. And for row transformation, 1 0 0 1 0 or 1 0. For row transformation, you have to go column wise. And while using column transformation, you have to go row wise. And what our target is what, to reduce the given matrix A into what identity matrix, because if I into A inverse will get what A inverse, and so our target is what LCM. So with this we have completed the inverse of a matrix of order 2 by 2 by using elementary transformation. In the next lecture we will do the same by elementary transformation of order 3 by 3. Thank you.